So we're live the whole time.
Great, and we have 6 minutes left until we begin, right?
Oh, and some echo. Mute.
You still have some echo, Gernot?
Oh, I have to stop my backup system. I have echo. Still?
No. Everything's fine now.
Okay. Yeah, it's the same because usually our neighbors, where about 20 students live, switching on the internet now. And the capacity of the 5 and 4 gigahertz channels is getting low. That's what I thought, but this was just my backup software. And the next thing I have to stop is OneDrive.
Oh, good notice here. I will do the same right now.
Stop for 8 hours. 2 hours will not be enough.
Yeah, I think we will need some time here. Especially me writing all that CloudFormation.
What I was asking, do we really want to do we count the time, or do we just discuss?
Well, we can count the time if we want to, but I think discussion would be enough. We could even go with the poll in Twitch and see what the community says about which tool suits them better.
Yeah, if the guys from Austria are enough there. The problem is that our old blog post is in German with the comparison between the frameworks.
That's unfortunate, but I guess we can make the best out of it.
I do not have the YouTube chat. Is this okay for you? Oh, we have the Twitch chat.
So let me try to obtain the YouTube chat here for a minute, just to have it
okay, I'm just
ready.
Switching through my scenes. Intro, slide, console, VS Code, no doku cam today, and there's one missing. Okay, I have the YouTube chat also.
Figured it out. Have it popped out right
now. Chrome.
Ready to work with it when we need it.
No, the wrong Chrome. No stream matcher. I wanted to do Excalibur. Yes. Is everything frozen, or are you just not doing anything?
I'm just not doing anything, just waiting till we're gonna start.
Oh no, a time warp. Just right now, I'm not seeing the camera from the Zoom. I'm only seeing the Zoom camera with a slight delay in Twitch. And so it's always the time warp.
That sounds crazy.
Can you send me the YouTube link again?
Well,
And this is the part I will cut out for YouTube.
I'm not sure if I can exactly because I just
okay,
have
then
dropped out the chat
never
now.
mind, never mind, never mind. So no beer today, but cool drinking. I have some ginger ale.
Oh, you're going to have a great day today, right?
Yes. So let's start. 10, 9. Okay, let's build. This is Marco and Gernot. Another time support from Austria, so to say. So not really from Austria. And Marco and me have a long running battle going on sometimes about the right tools. But joking aside, we do not really want to battle, but we are seeing sometimes in projects or with colleagues that it's quite difficult to choose the right tool. And sometimes there are just different styles. And so we decided to keep on further a long-running idea, also in German blog post, so that we are comparing SAM local versus CDK. So, and I wouldn't be the teacher if I had to say something theory at first. I am numbering my streams, and this is just that is season 1 is Honeycode. There's something missing. This is Amplify in Honeycode. I'm on it. It's almost ready. Then we have started the certification survival guide. There will be some things to follow, and we've started the serverless guides. And the last thing was last time streaming from the hotel with not so good audio. A Hugo website on Amplify, which was astoundingly easy. And the first time I finished early, just needed 20 minutes. So today we have a setting. We said, okay, we will make the standard serverless thing an easy architecture, because example architectures have many components and have some wild lambdas running. But I think to learn it, it's good to have easy components so that the logic and business logic is not so hard. So we just have a small lambda function, lambda function. And the function uses S3, not really uses, but an event, and DynamoDB. Because if you compare the frameworks, you have to have the resources and the lambda itself. One complex thing we have missing, maybe another time, which is API gateway, but we will see enough differences here. So the infrastructure is S3, DynamoDB, and Lambda. And we wanted to go a little bit with a timer, but timing is not the main thing here, because we want to clarify the differences and the pros and cons. We are almost going from 0 to doing. I have nuked an account. So it's really clean. Let's see what Marco have. And at first we thought, okay, we could go on Cloud 9 to really have nothing installed. But this adds a little bit more complexity. And surprisingly, everything is installed on Cloud 9. a month ago, CDK was not installed. Now in the standard image, CDK is installed, SAM is installed, and so on and so on. So these steps would roughly be, maybe Marcus is a little bit different there. We built a simple Lambda with the framework. Then we add S3 and events, and then DynamoDB, a little bit of testing, a little bit of updating, because testing and updating, we will see that there are huge differences between the frameworks. And if I say huge differences, usually we have another contestant in the ring. This is Terraform. And I've seen many blog posts on Terraform where the possibilities with Lambda were not really understood because there are different possibilities. If I'm here in my CLI, my terminal, the preferred method is to use code, to zip code, and make an update on the Lambda function with the bucket code. It's a little bit more complex because you first have to zip and load it up to the bucket. But if you do method 2 and going directly with the Lambda API, you have a boundary of about 52K and magically moving. And this boundary you will hit sometime. So maybe it's better to zip it. The method CDK and somehow also SAM is using is another method, generating CloudFormation, and CloudFormation is triggering the other events. And the next method would be, but that's not for discussion today because we want to finish today, not in the early morning. This will be a CI/CD pipeline. So keep that in mind when we're talking. And I wanted to say that without further ado, let's start. And we have discussed Marco will start with SAM. I will ask the questions. And after that, we will show the real stuff with the CDK. So Marco, please take over the screen share.
Yes, I will. Once you stopped yours, I can do it.
Stop. Okay.
All right, so let's directly, hopefully, jump into VS Code here. Can you see everything? Gernot, everything's fine here. All right. So we discussed and we wanted to start from zero, and starting from zero means we need to install, first of all, AWS SAM CLI. And therefore, we can use Brew, which makes it quite easy to manage all these packages on macOS and even on Linux. So let's add the AWS tab to Brew. And once that is finished, we can go in Brew install AWS SAM CLI.
Marco, you have to be very stressful. Keep calm. We have 5 years. So people are really listening.
We have 5 viewers. Wow. Okay. So that is great. So we are starting just with the SAM CLI installation here. And
okay, first question. What is the preferred installation method? Because sometimes with other tools are doing Brew, and sometimes I'm doing it with the installation batch script, and this collides sometimes. Do you always use Brew?
Well, if I have the opportunity to use a package manager, I for sure do. Whether it's Brew or pip depends on the tooling. So for SAM, I would go with Brew and stop using any other kind of installation method.
And they have the newest version in Brew.
Yeah, what they have here in Brew, because this is an official AWS tab, is they have the version 1. I'm not sure if that's the newest version or if there are some nightly builds out there. Probably there are. but this is the most stable version you can use for production systems. And for today, this will fit our use case. And then I already made myself comfortable in our Git repo for all of the trick benchmarks and created this SAM folder where we want to init our first SAM application. And it's as easy as hitting SAM init on the command line and letting it run. So this is a guided init here, and it will give us the opportunity to use quick start templates or custom templates. We will go with a quick start template, and because I'm a lazy guy, I want to go not with Go as you might do in CDK, but I just want to be simple here and go with the Python version. And now I have to give my SAM application a quick name. For this purpose, I just name it S3 Lambda Dynamo. And let SAM init everything we need to have for our first. Okay, so what we can do here now is start with all these crazy examples, right? We have this event bridge things, we have step functions and elastic file systems sample app. But as you mentioned in your introduction already, Gernot, we want to keep it simple here. And therefore, I'm going to start with the hello world example and just having it initted the way it is. So for here, we have a lot of code in here. We have events, we have hello world, which is the hosting part of our application. And we have tests for our templates and for our functions. But we also have this template here. And let me just get rid of the cameras here for a moment. Okay, all right. So what we have here is the standard CloudFormation template, if you look at it. But it's kind of special because it uses a transform here. And this is mainly what SAM is about, right? The serverless application model is just about transforming CloudFormation to write less code and get a CloudFormation output at the end. So it introduces some features and resource types as well. For our SAM demo or for our S3 Lambda demo, what we need is first of all, I want to start with the infrastructure. You might go a different way and first of all, write the Lambda function, but let's focus here just plainly on infrastructure.
Quick question.
Yes, for sure.
What else did the init generate? Just the files or some resources also?
Yeah, so yeah, the hello world Lambda function did a lot of things, if you want so. It created a serverless function. This is a SAM introduced resource type for CloudFormation. And it also created an API, which is implicitly created if we would run this here. It has an API integration, which would create an API gateway method with the function type of get and a path where you could hit the API gateway directly and get the function to answer hello. But all of this will not be relevant for our use case. So what is relevant for our use case is the function type here, and we will work with the Python runtime and the handler as well. But we can get rid of the events and we'll get later on. So, but first of all, I wanted to start with creating the S3 bucket because this is a very simple resource and this is the resource where I probably have to write the least amount of code today. And we got our S3 bucket ready. What this does is it creates an S3 bucket in the region. We're going to roll out this SAM template here and creates a random generated name for it. So that's our S3 bucket, simple as that. The next part we will need is
what
an S3.
Do you think about random generated names? Why not name it accordingly?
Yeah. So why not name it accordingly here? It just has two reasons. Because S3 bucket names need to be globally unique, as you know. And therefore, I like to have random generated names for developing and testing purposes, what this is. And we might, if we want to have a production setup, we for sure would go with the naming scheme and add some random stuff behind it, or even go with the naming scheme and have this unique bucket created for us. So the next part would be the Dynamo table, which we need. And this is of type AWS And just for you to note here, I could go with all these snippets here, but as we aligned, I'm going to write it by hand so that we have a fair comparison here, and not going to use snippets, just to be clear about why I'm typing all of that. And what I do here now is
that is the same thing with the CDK. You could for these you could just use a construct.
For sure.
2 lines and they say, okay, it works. But that's
yeah, for sure.
Learning it.
Yeah, for sure. And I think for this purpose, as this is a simple enough infrastructure, it is definitely good enough to write it by hand. But what I will do, and this is what I'm doing here, is I'm not going to use the CloudFormation DynamoDB resource type, but I'm using the serverless simple table type, which is introduced with the SAM transform, which, well, saves me some lines of codes here. And now, as you mentioned, I could also go with a generated name here, but for this DynamoDB table, as these just needs to be unique for my region I'm working in, I just go with the name I created and put it in. So the next part we need is a primary key. And as we all know, a primary key is just an identifier.
Just to interrupt you so that you get mixed up. Is simple table really so much simpler than DynamoDB?
I'm not quite sure if it's really that much simpler, because I did not look up the just DynamoDB part. But what we get here after I put in all of these lines is that we have a DynamoDB table with a primary key initialized, and also with pay-as-you-go pricing and capacities invoked. That's just what I think is good to use. And we have this kind of greater way to handle tags, because this is just a map of string to string, and with plain CloudFormation, all of these tagging needs to be an array of objects with key and value, and this is kind of well, it's kind of more work, I think. And then we can also just enable server-side encryption as easy as we would. And we have our DynamoDB table ready as well. And now comes the part where Gernot CDK would be way faster, because what we need for our Lambda function to interact with the DynamoDB table is an EM role. And as we all know, in tools like CloudFormation or even Terraform, writing all of this stuff by hand takes a time, but we will do it just for the purpose. So we go.
That was the thing. What Uwe really 5 minutes before that was asking before, because we are almost 60 consultants right now doing AWS since 7 years, I think, and this is a problem which is not really solved, how to easily get least privileges in roles. And there are some philosophies which say, okay, just use it, let the Lambda function run, and then analyze if what API call the Lambda function has made. But I do not think this is a good thing. So sometimes it's just hard work.
Yeah, well, I think it's easy, because what we do here is just using one API call for DynamoDB. And if you write the Lambda function yourself, you probably know what the Lambda function is going to use as least privilege, and what kind of rights you need. But it could get a hassle, because if you don't have control over the source code, you will have a lot of work to do finding what kind of EM permissions you need for the correct function of your code. Sure. So let's give it another action. And we need assume role. So this is the first part we need, because each role is combined of a trust policy, which I'm writing right now, and a permission policy, which will be the next part. So let's put in some description here, just to know what kind of role we are writing. And this is the Lambda execution role.
To be fair, in the first part, I was thinking, oh, that will be harder in CDK, but you're right. This is the part where CDK then shines.
Yeah, this is for sure the part where CDK shines. And we will see that later. But what I'm not doing here is I'm not using managed policies. I'm not sure whether you do in CDK or not. But for this purpose, I think it's easier just to write down the least privileged policy by hand and see how that works. So first of all, we need a name for
managed
our policy.
policies are bad, but people does not notice it. It's easy to use them, but they always resource asterisks for all resources. So if in a review I see managed policies in production environment, I look deeper.
Yeah, well, what I not meant here is using AWS managed policies, but using self-customer managed policies, right? So I could create a managed policy out of this part and references in the EM role, but I'm not doing it. So I'm just writing these lines of code because they are not that many actions we need. And the first actions we need are just the the logging permissions, which we could also leave out. So our Lambda function would not be able to log all its output, but that would not make the function not work on what it should do. But for troubleshooting, that is always a bad idea. And so we just give it the 3 permissions here for logging and put it on resource asterisks. I know this is not the best idea, but as Lambda creates log groups and log streams themselves, I think it's good to start with a star here because, well, what could you do? You could create logs with this Lambda function. Well, that's not that big of an security breach. But for the next action,
or you could use the Lambda basic execution role here as a.
Well, yeah, sure. I could reference that, but yeah, that's the part with the managed policies, right? We could use
the same in this case. It's the same because it's resource. But I think also it has advantages to create it all by yourself from the start, so that you are in control.
Yeah, I think that's the best part here. So, and now we come to CloudFormation kind of magic, where we just get attribute of our created DynamoDB table and never have to worry about the name or the ARN. And this will come later on as well. So now everything is kind of ready from being the S3 bucket and the DynamoDB table. But what we now need is our Lambda function, and I will just rename it just for the purpose and name it magic function so that we will see everything that gets wrong here. And for sure, we'll rename the Qt URL as well, just so it's consistent. S3 Dynamo Magic. And if we do that, this code URI here just relates to the part where the Lambda function code in the end is stored. And therefore, we need to rename this folder as well. Well, this was wrong.
Okay.
And so
that's the difference. In the templates, there is no template in CDK for the serverless function, so you have to create your Lambda directory yourself.
Yeah, well, if we have a look in it, well, it does not do that much. It just has the requirements txt, we'll come to that later, and the application handler and an init function. But yeah, as you mentioned, for CDK, you have to do it on your own, for sure. All right, and then we go into the events part because this one needs to change. At this point, it just is an event for an API gateway here, but we want to have an S3 event. And therefore, we change it to events S3. And now it comes the part where we just need to make a reference to our created bucket. And as we all know, we don't know the name of the bucket. The name of the bucket would be fine here. As we created with a random name, we just can use CloudFormation with the reference function to input the right name. And then we need to say what kind of event we want. And for here, we want to have the created object, object created, sorry. Object created event, and we want to have all of them. Whether it's a put, an update, or that does not matter. We want to have all of these events to trigger our Lambda function in the end. And now to get the name of the DynamoDB table to our Lambda function, I'm going to use the environment here. And I put in a variables part where we can just put in like table and reference that to the name of the DynamoDB table. And we will see what that does. And now just to clean up the outputs here a bit, because we don't get this API created, and the hello world function is not called hello world function anymore, but it is an S3 Dynamo magic function. We will name the output accordingly.
But that's just a logical name.
Yeah, well, that's just a logical name for sure. But just
so
to make
you're
it
right.
consistent.
But if you're lazy, you could leave it there.
Yeah, for sure. But I'm not lazy because I'm the one typing all of this crap. So I think, yeah.
I fooled you with that. Snippets are allowed. I will copy and paste all.
So I'm just copy and pasting now the name because you said that. And then we'll say this is my Lambda yum role and get the yum role name as well. And this is not an implicit created, but it's an explicit. All right, and that's everything we need to have the infrastructure ready. So we have 80 lines of code with some blank lines and with some kind of comments in here, which will be handled and which can handle all of the infrastructure we need for this example. And just to be sure everything works, we just go in here and use my letsbuild profile to validate whether I did not make any typos and validate it with Sam. Okay, so the typo is in the command here. Sam template not found. This is sure because what Sam did also, because we named this Sam application something, it created a subfolder in our Sam directory with the name S3 Lambda Dynamo. And so we need to navigate into that as well, because then we can use the Sam commands on this template.
Which parts from the validations are done here? Because usually with CloudFormation, you have the problem that you have about, I don't know, 5 levels of validation. The first one is a linter, the second one is the CFN linter, and then when CloudFormation really comes to the service, you have the third thing.
The third thing. So what do you mean with what kind of validation is done here?
I mean, is this just local validation, or is this using CloudFormation API for that?
Yeah, it's using the CloudFormation API, and you can see that in using the profile as well, because you need to have credentials to use SAM validate. And what I would assume here is with SAM deploy, it's the same. It's just a mapping onto the AWS CLI command, CloudFormation validate, if that's there. But it for sure uses the CloudFormation API in the background. Okay, so that's everything we need to do here, right? So the next part would be going in and creating the Lambda function. What we don't need is this request part here. We will just need Boto. And therefore, I'm just going to put in the latest version of Boto here, just to be sure that my Lambda function uses the latest version of this library. I could also go with the lower version, and I could also go without even installing or saying I have a requirement for Boto. And Lambda would inherit Boto package just as it is in the Lambda environment. But that's most likely not the latest version, and we will lose some features. So I like to always pin the latest version, or even the latest version when I was creating the Lambda function just to be consistent with the API I'm going to talk to.
But your upload packages will be larger.
Well, yeah, kind of. And this gets a problem later on if we have many Lambda functions, for sure. And then probably we would talk about creating Lambda layers and reference these layers.
Yeah, definitely.
All right, so now comes the part where both of us will have some work to do because the Lambda function does not write itself. I will need some packages here. I'm going to use these 4 packages and I'm going to import them.
I will not type the whole Lambda function.
You will not type the whole Lambda function?
No.
All right. That sounds like you have a snippet for that.
You know me, so my first guess was to use Go, but I wanted to show features, so I...
All right. That's fair enough.
Sticked with TypeScript, and I should have used Python because there's another feature, but this will be for a later day.
Yeah,
but the question would be, what if, maybe you will come to that, you have a Python package which needs to be compiled on the Linux version?
Oh yeah, that's a problem. Well, that's kind of a problem, right? So because we know that the Lambda function itself runs on an Amazon Linux AMI or Amazon Linux environment, and you cannot just go on a Linux machine and run it. But what you can do with SAM is you can build in a container, and we will see that later on. And this container, which it's built in, uses all the requirements txt, and this is also the environment the Lambda function later on will run on. And so your dependencies are managed by a requirements txt, and if you have a package that can be installed by a pip, that's absolutely great here. So, and now I'm just doing some kind of cosmetic here, showing you some f-string features which were announced in Python 3 to have a great logging output and knowing which kind of version of my Boto is running. So, and this will lead us, if we don't put it on info, but warning, this would be the first part where we could run this Lambda function just for the sake of it. And therefore, I'm going to have my SAM build the Lambda function, and I'm going to build it inside a container. And this is what this -u is for. You could also write -- use container, but I'm just a lazy guy here.
So what steps does the build perform?
Yeah, we will see that. What the build performs is it downloads the container image, which will be run on Lambda later on. As you can see, it's fetching the Amazon Python 3 image, which then would be the image running the Lambda function as well. It's mounting some volumes to have the Lambda function code inside the image, and then creates a Docker image out of it.
Didn't they use
and also it packages something,
before?
right?
Didn't
Pardon?
they use the LAMCI project containers a while ago?
Yeah, they did, but I was kind of stumbled today as well because they have now their own SAMCLI build image containers for their different languages, and they switched to that, I think.
Because in preview, CDK also uses the containers from SAM. So SAM is the base.
All right, that sounds great. And we have now the option to run locally. So we can use SAM local invoke and just run with an event, for example. If we go for, like, say, events, and we have an event in there, we will come to it and we can run it. So also we can use a profile here just to have credentials available to our Lambda function.
And to give credit to whom it belongs, this is the part where SAM shines, because the official recommendation from CDK is if you want to invoke your Lambdas locally, use SAM for that.
Yeah, and what you can see here now is that I made a very bad mistake in writing my code because I need version, but I'm not sure why it's not putting out its both. No. Oh, all right. Oh, I see where the problem is, right? No, it's not. Why is that not giving me the goddamn version? Let me look that up. All right, let's see. It's that way. So this is something you should know about Python. You are not supposed to use these private modified variables here or parameters, but you can. So there's no enforcement on having something like private in SAM. So, and for now, we need to rebuild all of that because I made a change to the source code. All right, so now we can just invoke it again and see if I fixed my error here. And my Lambda function would run now. Yeah, and as you can see, it would run. And there's something interesting here. It references the Boto version I just put in the requirements txt. So this means if you use SAM build, it directly looks up the requirements txt if it's located in the source code files and installs everything you put in as a dependency here. So we are good to go further. So the next part would be to define a function to obtain the name of our DynamoDB table. And I like to name it getEnvironment. And just put it in a function here. And what that function does, it just returns a dictionary of entries with table and the auth function getEnvironment. And we go for the table. And this now references to what we earlier did in the template. If we look that up, we have an environment variable that is named table on our Lambda function, and this references just the DynamoDB table name. And what we can also do is we can give it a default. So it will automatically fall back to this default table name if the Lambda function table name or the table environment variable does not exist. And then I just can get into my
almost
Lambda
exactly the same thing what I was doing. So must be the right way.
All right. So
not because I was doing it, because we both.
So, sounds like we know what we're doing. I would question that. So and then as well, we go for greatly introduce f strings and just put out a warning with our environment. And therefore, we can now build again our Lambda function and could run it again before we even go further. And what we could also do is we can return true here at the end. It does not matter because we don't have someone listening on that response. But just for the sake of not having null here in the Lambda function, I'm just going to return true. All right, so if we invoke it now, we should see two logger outputs as warnings, and we will change that to info later on. And what we see now is we have the Boto 3 version as before, and we have the environment. And the environment is related to the array, and it's saying my DynamoDB table. Because what happened here is, as we build the table, it does not get the reference, but it gets the logical identifier in it if we locally execute the SAM CLI script here. And therefore, it just puts in my DynamoDB table as the table name. So it does not fall back to the default table name because the environment variable was propagated with the logical identifier via SAM. So then we can go on. So the next part we need is we need to have some functionality to look up events, right? And therefore, and I'm not going to put that event and write it down myself because that's something you would always look up in the documentation. I'm just going to put in the event JSON, a simple event, which just is the S3 upload or trigger event with some predefined values here. And what we should focus on is the key here, because that's what we want to put in the DynamoDB table. And let's call it let's build. And then see what happens. So because the next part will be iterating over all of these records. And if we look at this event here, we can see it's a dictionary with records, and records is an array of dictionaries, and we want to iterate over all of the records we get in that event. So for record in. And now what we can also see, if we look up the header of the Lambda handler, we have this event already put into us. So when S3 triggers our Lambda function, the event will be already delivered to us. So we can work with the event and then can work on records and get it to work. So what we now need to do is obtain the item key. And item key here just means the name of the object that was uploaded. So we go further into the event here and use the S3 key just to go into the dictionary of S3. And then we go further in the dictionary of the object that was uploaded and triggered the event. And then we go into just plainly the key and we are good to go. Now comes the part which I will put in here, but does not work at this point, just to have it here already. Which is the response of the put dynamo item call we implement later on. And we will give it some form of an environment. And we will use in our environment the table we already created. And on that table, we want to create the item with the key we obtained before. And I'm going to put this in a comment here. But what we can do is we can print the item key, just to verify that we did everything right. Therefore, we again build the Lambda function and see what happens.
But you haven't loaded up yet. You haven't
no,
created.
This is all local. That's all local. I did not create anything online, and we can look that up as well. Because I have this great AWS part here. And what we are going to work on is the Milan region. So I'm not nuking my account for this, but I'm using a region I did not use before. And so we're going to use EU South 1. And as you can see, we can refresh that as well. We don't have CloudFormation stacks and no Lambda
I forget
functions.
Everything.
Yeah, but if you forget to delete this here, you will not pay anything, right? Because this is an event-driven architecture, and well, yeah, you will pay some kind of cents for S3 leftover objects, but yeah.
Yeah, it depends on the new standard type for pricing model for DynamoDB. Otherwise,
Sure.
with the old model, you would have paid €5 or something about that a month.
Yeah, sure. But as we figured out here, what I want to do now is put all these logging outputs to info just to get rid of them. But we can see we have the object key obtained successfully from the event. And now comes the part where we go into live testing and where we must leave the local environment because we don't get the correct table name in the environment because reasons. So we need to create this function up there. I already referenced, and I'm going to name it table name as the first parameter to this function. And I'm going to put item key here as well. So, and
I think local testing is great, but the problem is sometimes that if you didn't get the policy right, then you're testing local with your policy, or is the IAM policy applied you created for the Lambda?
No, it's not, because, well, therefore we need to roll that out, right? And then we could create a profile and assume that role if we're allowed to, but we would not be allowed to because it's just allowed for Lambda to assume them. But this is where the AWS toolkit for VS Code comes into play. Once we created all of the rest, the leftover stuff we need. because then we can also locally from this machine here, without leaving VS Code, just trigger the function and, well, see what happens. So we're going to use the put item on the, oh, that was wrong, on the Dynamo client from Bodo, and we're going to put in the table name, which is our parameter up here. And then we put in an item. And this is just plain syntax we need. But what we did is we named the item primary key object ID. And we need to give it what kind of value it is. It's a string. And we need to give it some kind of value. And the value is the second parameter of our function. And then what I want to do, because I want to see what happens, I want to return the consumed capacity. And I want to have the value of total. So this just gives me a response with consumed capacity in it. I did not need to do that because the Lambda function would run. But as we use a DynamoDB table with pay-as-you-go pricing, it would be important or good to know what kind of capacity I'm going to pay for each request. So, and then I'm going to return the response. And then I can just put in this part up here. And what I can do now is I can print the response and see what happens. So at this point, I could not further locally invoke this function because the table name would not be correct. And if I would try to hit the Dynamo client with the not correct table name, it would just say, well, the table you're trying to run that in does not exist. So what I'm going to do now is I'm going to build the package I'm going to deploy with SAM to the live environment. And what we can do then is we can use SAM deploy, and we can use the guided option here just to give us some hints on what kind of values we need. Also, I'm going to put in my let's build profile. And I'm going to say I wanted to have in the region use South 1. So what this does is says, well, give me some arguments, which I can then save in some kind of SAM config toml, which will then act as defaults once you run SAM deploy. And as we already did, I'm going to name this S3 Lambda Dynamo stack as my application name. And it will be in the US South 1 region. That's good. And I want to initiate a deploy. Well, I want to have the stack set reported to me before it deploys these changes. As well, I want to create resources and rules. So what this does, it just informs the CloudFormation API that I'm willing to use IAM capabilities within this CloudFormation stack. And we need to because we created the IAM role for the Lambda function. And then the last argument here is, do you want to save all these arguments? And yes, we want to do that. So what this does now is...
question, is there only a toml possibility for the configuration?
Well, I'm not sure if there's another one, but this is the guided version or even the standard version, and I just stick to it.
Because toml is usually quite easy, but most of the time there's a YAML version also.
Well, this is not that much of information. I guess probably there's a YAML version as well, but if it's just toml, I think it would be fine because it's just like 5 values here that are stored in there. All right. So what this all does now is creating and uploading my Lambda code and triggering the deployment functions. So, and now, and this is similar to what CDK would do. It lists all the operations and all the resources that are going to be created. So we have our DynamoDB table, we have our EM role and S3 bucket, another EM role, the Lambda function and Lambda function. So, and here we see that I missed something because we have these 2 roles here. And this is the magic role, which is implicitly generated by CloudFormation, by SAM CLI with the transform. So what we missed is using in our templates YAML the reference to our created yum role. And once we do that, so we say, no, we don't want that. But we put in here a role. And this now is the reference on the my Lambda function.
And this is a totally different thinking with CDK, because with CDK, implicitly a role is created and you can add something to it. So you wouldn't have notices because there would be a role.
Yeah, so but I just noticed it because here it's always the name as, or the logical identifier, it's always the name of the function with the suffix of role. And well, this does not make sense here, right? We don't have two Lambda functions and we just want one role.
Oh.
All right, so the build is complete, and then we can go to the guided deploy. And as you can see now, because we have the samconfig toml file here, which says all these deploy parameters and whatnot, everything is stored in here. I did not even, I would not even need to put my profile in again. And this is some kind of problem here.
Sorry.
Yes, for sure.
Line 6, the bucket for the deployment. Have I missed it? When was this created?
Yeah, you probably missed it. This one is created in the deploy. Once you use sam deploy, the first steps is creating this bucket and uploading the S3 artifacts.
Because with CDK, you do it explicitly, and they already have a new version of the bucket deployment. As you can read in our blog posts, AWS-blog.de.
All right. So now it's creating everything. And once that is done, we have a running application and we can use it for live testing. And that's the moment I'm going to hydrate again.
Gives me time for a question, because this is straightforward. I've talked about the different possibilities to update a Lambda function. Is this the same as in CDK with SAM, that all the time, each time you update your app.py code, there's a change set created, or is there a possibility to make it faster like in Go serverless?
Yeah, what you can see is it's going to use CloudFormation events from a change set. So yes, there's a change set each time you update the Python, because you for sure need to rebuild all your deployment packages and it needs to be uploaded again. So, and that's what you wrote in your blog post, going to have very fast deployments. That for sure would work, well, needs to be done here as well. So because it would be a slow deployment.
Yeah, I think this is one thing. If you're fine with that, I think the framework SAM and CDK is a very good choice. But if you say, no, I don't want to write another script for that, it's too complicated, then maybe you stick with Go serverless, which has a special function for fast upload, which is the normal upload from the API point of view.
Yeah, for sure. And what we can see now, everything is created, and we got our two role outputs here, which were created. And as you can see, it created some form of dynamic names here for the role and as well for the Lambda function. So what we can do now is using this AWS Explorer here on the side and update it just to see that in our Milan region now, we have a CloudFormation stack or even more than one, and we have a Lambda function. And this is the first part here, which just created the managed bucket. And this is the second part, which created our stack. And we have in here the Lambda function. And the important part here is we can now invoke it on AWS. So we can, without leaving the Visual Studio Code here, we could use a fileless payload, or we just can use the sthroughput event, which is similar to the one we used for local testing. And we can focus on that. This says we have the happy face JPEG here, and then we can invoke it directly from our Visual Studio Code and just see what happens to the Lambda function. And as you can see, we get a consumed capacity here with 1 capacity unit. So, well, we have to pay for 1 capacity unit, I guess. And it succeeded. So we got to the true return value, and we used a duration of 900 milliseconds for our function to run and put the event into the DynamoDB table.
I always find it funny because they split it, AWS split it up the init duration from the cold start so that you can see the real duration of your function again. Because
yeah,
last year it was like the first time you hit the function, it takes hours, no, seconds. And after that, you just need 300 milliseconds or so.
Yeah, for sure. And what we now need to do, and we could also stay here in the in this Explorer here and upload a file to the S3 bucket just to be sure that, and I'm going to use the image you created for this architecture and upload it in the S3 bucket just to see that that would also trigger the Lambda function. We could not see it directly here, but if we head over to the console, and now I need to change my share to this great thing here. All right, so this here. Come here. So now we should see my browser. And what we can do here is go to the Lambda functions, and I'm already in the Milan region. And we can see that this Lambda function exists. It's kind of a big Lambda function for what it does with 7.3 megabyte. And we can see the monitoring if we were keen enough to wait for like 5 minutes. But what we could also do is head over to the logs and just have a look in the runs that were created. And we have here the created log group of the latest function. And in there we have the 2 runs. First of all, we have the one that created, well, the happy face JPEG entry. And then we have the second one that was triggered via the upload to the S3 bucket. And what we then can do is we can go to the DynamoDB tables, find the correct table here, and just look into it. And we probably should have 2 items in here. The one from the happy face and then the happy serverless standard PNG. And this would conclude like my demonstration here for Sam.
Okay. This was, I think, I thought this was the time we are needed for 2 sessions. Of course, I'm a positive guy. No, I just thought it was very good that you explained the Python also. I will explain the TypeScript also, but I will not type it because it takes longer. So what would you summarize? What are you, from your very personal standpoint, what are the advantages or the disadvantages for SAM Local? This is a tool for people who like to, don't know.
Well, this question is kind of hard. I think it really shines when you have great or bigger APIs you want to integrate, not just an S3 event, but having like multiple HTTP APIs with a lot of Lambda functions and having it managed in a single SAM application. I think this is where it could shine. And if you don't need some resources different than serverless. So if you have just this simple serverless application and it's your business logic and everything is built around it with an API in front and all the integrations you need, I think this is for testing. It's very good because you could also locally then test with the API events and see if your Lambda functions behave correctly, if they don't have some sort of dependencies to resources that are also created in the same stack. I think that is where SAM could really make an impact. I would not use it for working with all AWS resources because it's very limited. It's mainly just a serverless application model, and it just applies in a transform to CloudFormation. And I think if you want to use like more out of the AWS scope than just serverless, you could stick to serverless for your serverless applications. but go for other tools like CloudFormation plainly, or even CDK, or third-party tools like Terraform to manage your infrastructure.
But what's I had the idea when I saw the tooling from the VS Code, because I do not use this, that SAM is just tightly integrated into the AWS tools. It's the same with Cloud9, that you just can import and export and so on. So then, please let me.
Yeah. So let me just.
Okay, I will just kick you out. Yeah.
I've just stopped it.
So I have to choose the right window. So you see, at first I will go to the console. As I watched your talk, I was really thinking, oh, that's a good idea. You could make it this way, but I will do it the way I prepared. And yeah, we'll just have a look how this turns out. So at first, I had created myself a few other accounts, and so I really have an account which is quite nothing in it in Frankfurt. So you have no CloudFormation, no Lambda. And for that, I have used the tool AWS Nuke, which just repeatedly tries to destroy everything. And I really sweated, how do you say, had a fear of using it. So now let's come to CDK. I will first build the Lambda, then add a simple event, adding DynamoDB, and then testing and updating. And the problem with both the tool sets are that fast updates are not integrated, but you can do this. So this Twitter post got retweeted many times because each and every morning I have to do CDK install, because usually each week there is a new version. But that is not such a big problem, because with our templates in the tecRacer GitHub, we try each new version, and usually you have nothing to change. What we have to do is, at first we bootstrap the environment, because CDK itself uses the deploy bucket, which does not create implicitly, but we have to do this. So at first I will switch to my profile. And look whether that is working.
Okay, so you're using Awesome here. Just a quick question. Why are you using Awesome and not the profile parameter on the commands?
I'm using both.
All right.
I want to make sure I'm really in this project, in this account, because I'm in many projects for that. So with CDK, you have two types of bootstrapping. And there's a new construct, CDK, the modules are called constructs, which creates a CI/CD pipeline for you also. And this would be the thing I'm using right now. So I'm telling it CDK new bootstrap equals 1. Then I'm just exporting my account, and I will be lazy here. My region will not be Milan, but this would be a good idea. And I'm also using my profile.
So what I know for CDK is that it, kind of lacks support for regions from my history on deploying with CDK. How is the support for the Milan region, as this is a fairly new region? Are you sure if it would be available?
Yes, because usually CDK has nothing to do with supporting regions, because the interface is it's using CloudFormation. And maybe what you mean is if you want to deploy to different regions, and that you just have to do explicitly. You create an environment, you say in the environment, okay, this account in this region. And with the CDK pipeline construct, it's getting more easy, because it was a problem before to make something like a stack set. So,
yeah, so what I meant here is that the CDK metadata, which gets deployed, had some issues with newer regions, and I faced it when the Stockholm region launched. So that's what I was referring to. But yeah, I think they fixed it maybe. And what for sure you always could do is just synthesize CloudFormation out of it and deploy it by hand. Sure.
Okay, I've not worked in the other regions, so just to be a little bit quicker. I've done copy and paste, and this is the NPX is just a user version right now. It's a bootstrap. I'm using my profile, and this is the same line you can get in the blog post. Then you only need that for version 2. You have an execution policy, and okay, this is not quite least privileges. Using administrator access for concrete a project, you should use less privileges, and then you say, okay, it's this account in this region. So, and then we have to wait. Okay, what this now is doing, it is creating a CloudFormation, and with each call to CDK, it will look up the CloudFormation stack and get the outputs for that. So we get the CDK toolkit stack here, and in the output there will be our add3 bucket for that. So while this is working, and because with the deployment in the code build, it also creates a few keys, and so it's taking a few minutes. I will do nothing because we have a problem with that. Okay, I just thought about copying the Lambda function, but you do not really need this step right now. You need a deployment bucket if you want to deploy Lambda code. And this is what I've shown in the beginning here. Yeah, so that if you just create an S3 bucket yourself with the CDK, you don't need your deployment bucket, but we're using Lambda, and CDK also uses change sets, and so you need a bucket where the code is uploaded. And this is the same as almost the same as SAM local, that CDK creates CloudFormation. With SAM you create it yourself and then load it up to AWS. And that's, I think, quite a good thing, because this is a common denominator. You have to know CloudFormation if you work with AWS. So it takes some time. We have some events here. And we not only have the staging bucket, which gets a unique name, we have some encryption thing and deployment role. And this is all for the code pipeline, which could be automatically created. And so it's a good thing if you start now with the CDK to do that. So now we should be in an empty directory. With CDK, you have to use node. So node should be there. Then you need TypeScript, the TypeScript compiler, so that should also be there. And then the CDK version. if you have Node and TypeScript, and in the Cloud9 environment, CDK is also installed. Usually what you do each morning is install the CDK, and I'll do it globally. Some people like to install everything locally so that it got not spoiled everything, and this could be a good idea if you use deployment pipelines, because it's better to to make isolation for that. So no new version, that's good, but updated one package, no. So then CDK also has an init for example, but this is only, you can have just one example project, and this is with SQS and SNS. And if you want to start something, you just say, okay, please init an app. And then, because you're programming it, you have to choose your language. And they're working on Go now. So
from my understanding here, this language equals TypeScript. I think this is the default value. You might not have typed that there, right? So you just typed it for
usually it's asking. If you do not type anything, then it's asking.
All right.
This is so, but it's a good discussion. Is this the default? The thing is, you can use other languages, but it's automatically translated from TypeScript to these languages. And so usually 90 to 95% is almost the same. So if you want to stick with your language like Python or Java, it's good. But if you can choose, I would choose the first language. And because there are some work behind the scenes, you see that it's taking longer than you're just manually typing. So that gives us the time to look at the VS Code, what is going on right there. So we have these libraries. Usually your main program is in bin. And this is TypeScript, which is object-oriented JavaScript. And with CDK, you have to say, okay, which library I'm using. And then you create an application, and the application can hold different stacks. And this stack, our work stack, is created in the library section, and it's prepared to get code. So some time. And this is the thing with TypeScript. It's really, you have a medium-sized project and you have hundreds of libraries, which makes it flexible, but it just creates thousands, really thousands of files. So we first will create a simple Lambda. And for that, we have to tell CDK, okay, we need the Lambda code. And I will import two things. npm is a package manager, install. And the first thing is AWS CDK / AWS Lambda. And another thing what I wanted to show is AWS Lambda Node.js. And there's also a Python version. And this creates a Docker a container with the same images as SAM to build the languages.
So I'm assuming here that these AWS Lambda packages are already officially supported packages from AWS as well, right?
Yeah. So, and here, CDK / So and I will do all imports right now, but I will use them step by step. Of course, it takes some time. So, come on. I have also experimented with AWS code artifact, and it's more stable than NPM because in the time I experimented, NPM got hit again, or Akamai had a hiccup, but it's a little bit slower. What I'm now will use is Packet Manager, which uses local files just to save some space on my hard disk because it just makes links and does not download it again. So what do we need? It's always AWS CDK, AWS S3. Then we need AWS CDK, AWS S3 notifications,
So I think this is time for a question here, because what I know is that you need to be careful with versions of modules and the main version of your CDK. If you're now linking them locally, how do you handle versions for the modules?
It's handling the versions. It's just it does the same as NPM, and it's storing each version in a local cache. The same thing which Yarn 2 should do, but I have not got it working. And so I have just each version, but the 1.56 and the 1.57 I have in one cache, and it's linked against that. Not linked in the compiler type of way, but linked in the inode type of way.
All right.
So that
makes a lot of sense.
Should be all. So then we can yada. And just to show you how many, now it's linking to the cache, and just to show you how many this is, that means if we just make a word count here, so we have about 500 modules just for that. So what we now have to do, TypeScript have to be compiled to JavaScript to let it run. And for that, there are predefined scripts, and this is the watch script. And with VS Code, you have a shortcut for that. You can say, okay, run a task, the TypeScript task, and run the watch task. And what that does is that each time you type, it compiles it, and you see the errors right away. So after we have done that, we can start to code. If you are now using something, it has to be imported. And this asterisk here is somehow not the real right way to do it, but you import each function on your own from the different packages. So we can use here AWS Lambda, and the imports will be done automatically, and will be a little bit lazy on that. And now we are using the special Lambda node.f for that. So everything is okay. That means the packages are there and loaded, because sometimes Visual Studio Code does not load it quite right. So then we create a function. And because everything is an object, we create the function as a const. Const is the right way to do it, because we will not change the variable fn afterwards. and we will have a node.s function. And it's automatically imported here. So this is with the right plugins, a good thing.
So I don't think you need any plugin for that, because TypeScript is a Microsoft product here as well. So it's tightly integrated in VS Code, but this is cheating, I guess. So I could have used my snippets, right?
This is even more cheating, because I have a plugin which is tab 9, which uses machine learning to make suggestions of what you're typing. So with each construct, you always have to say, okay, this is for that class, and you give it a name. I will make it shortly, and then you give some parameters for that. If you haven't, oh, that was too fast. So we could, no, this is not right. Okay. This is the magic I need in this time of day. So, and now usually you have to say, okay, here is your code, and this could be a directory or a zip file. And with the special node.js, you say, okay, I have an entry function, and this is in the Lambda subdirectory, and it's index.ts, and then the construct handles the compiling as well. Then, like in all Lambda function.
Yeah, so this is just like the code URI on SAM, I guess. So where you just link it to a directory, and then it will handle all the build process in the background, right?
Yeah. And it's not so long ago, it's just a month or so ago, that they started to using Docker containers. And sometimes in the changelog, this was just one line, but I think it's a huge step forward. Then you will have a runtime, and you see here, this is my suggestion from tab 9, because I'm typing runtime often. And this is really from TypeScript, because this is the right property. If you look here in the code description, everything is documented, so you see which. So now, runtime, then it should be automatically imported or not. At runtime, and then we will have node 12. Yeah, that should be. So, and this is my Lambda function, and this was the same idea you had. Make an output, and output is such a basic function that this is not done with a construct, because construct, there's always some logic in it, and all the classes with CFN are just pure cloud formation, but you do not need any logic in it. And so yeah.
So what does this mean? These are pure cloud formation. So okay, could you
automatically generated from the cloud formation schemata.
Yeah, all right. So what I noticed is if you work with CDK and TypeScript, you have these grade construct, which are typed if you want to. And then you have these, cloud formation or CFN prefixed classes. And what I think is they just plainly string based, right?
Yeah. And that's the thing. You get advantages if you use it type-based, and so one after the other, there will be construct for that. So because we have not so much time, I will just program everything. Now we have the Lambda, and usually I wanted to do something like that we now could make a div, and this is the creation of a change set. And it tells you what is created. And there's also the metadata you were talking about. Oh, and I need some more water. Better bring me some water. Okay. The file is not there. And so it will not work. And I think this will also not work because there's nothing really helpful in it. Now will start to cheat a little bit just of the time because the Lambda function itself, I did not want to discuss so much. And so I will just copy and paste the index TypeScript. And I will I will show you later what this is all about.
So what I see here is you have the index TypeScript and you have the index JavaScript. Do you need both of them, or would the JavaScript part be created by CDK?
You only need the TypeScript. If you, just a moment. If you use a special construct, everything is done for you. And you could use, and sometimes I'm doing this, the preferences from Visual Studio Code to just filter it out, because you shouldn't directly do anything in that. So the last thing that we need is a TypeScript config. And the funny thing is that tsconfig.json, you have to be aware that you have two TypeScripts. It's the CDK infrastructure TypeScript and the Lambda TypeScript. And it's easy to get confused. And so it's a good idea to tell CDK, please leave the Lambda TypeScript, leave it if you doing a normal deploy. But the construct, which is aware of the TypeScript, this will automatically deal it with the right way. So you could, if you have problems with that, say, okay, the CDK out where the things are generated is left out, and I will also leave Lambda out, because this process down here, which I will start again now, it would also compile the Lambda. But if you have different compile settings for the Lambda as for CDK, then you will get a problem. So just split it up. So again, run task, and we have recently used watch in this. And usually we have to deploy the Lambda, and that means all the I'm now switching to the Lambda subdirectory. And now I'm at the level of the Lambda itself. And you also have, and I will use fin now, not npm. You also have to install the packages so that the node modules is filled, but you do not need so as many packages. So going back to our infrastructure. So this is the Lambda, and it would now work. Going back again, how many time takes this? Yada, yada, yada. 30 seconds. And maybe now our CDK diff is working, because at first it looks up the Bootstrap CloudFormation, whether the bucket is there. and then it compiles, and also it checks the Lambda if it's there. And the module which takes the Lambda TypeScript is using subdirectories to cache some of the things. And that's what I meant was it's really quite slow if you update the Lambda a few times. So you could do local debugging, or you could directly upload the Lambda with AWS Lambda update function code. So you see it takes some time going further.
So just to fill this gap here now, because we have some time, I guess, what is your preferred way of handling Lambda debugging? Would you run it in the Lambda environment, or would you go with local debugging?
It totally depends. The best way from the engineering standpoint is to do local unit testing, and your main Lambda is just calling submodules. That said, even if you are doing these unit testing, sometimes you just have to step through. And then sometimes I'm taking SAM, because with CDK, it's also the preferred way. You generate the cloud formation and you do SAM execute local. But if you have a fast deploy with an update function code, which is just 2 lines, I a little bit tend to do it online, because then you have the right you are a little bit nearer to production. You have the right policies and so on. So that means we can now go on with the infrastructure. Let's have a look. Oh, it's still working. Okay, that does not feel right, but maybe it's the OBS which takes CPU power for that. So now I will make a bucket, and this is also that if we need to reference the bucket, the same as a ref you did in the cloud formation, we have to create a variable, and it's not variable, so it's constant. And for that, we need to instantiate bucket and just call it incoming, because, or try to call it incoming. And again, please automatically, sorry, that was the wrong key. Really quite slow. Please import the buckets from S3. That is one thing you have to watch out for. If you automatically import it, sometimes things have the same name. And if you import the wrong thing, not so good. So least privileges, I will just say, okay, block public access. And you see here from tab 9, and this is a real one, which really is a property of this construct. And I will say block public access. Okay. Block all, because just want to use it internally. Then the same thing with the output. So we make a new.
So you're using here a random CloudFormation generated name as well, right? Or CDK generated name.
All right. Yeah, and the name usually is generated from your logical name here, and then some GUID. So now again, always this bucket name or bucket name output. And then you have the value and the value. And this is a little bit more easier than typing it manually. You can refer. No, something's wrong. New CFN output. No, it should be right. And then you see everything. It could be referenced, and we will reference the bucket name, which is a little bit here. So let's have a look. Okay, the first time took some times, but these are all the things which
Yeah, so and if you
deployed.
look here at the conditions, right, this is where all the CDK metadata and the regions are related. And I think that's the part I was referring to when I talked about this region support.
I didn't use it in the newer regions. So the bucket name. Then the same as you, as I said, okay, I had the same idea. We have to tell Lambda about the bucket name. We do not really have to tell Lambda about the bucket name because it's in the event. But for the sake of teaching, I want to add the environment. So we have Lambda add environment. And our environment variable will be bucket. And we are referencing to the bucket name there. And that means going to the Lambda. In the beginning, we have here a constant which fetches the environment from the process with bucket name. And you had a standard name and I had undefined for that. But I think this is a common way to interact with your Lambda. So, and now the thing where CDK really shines. If the use case would be that the Lambda function has to read the bucket, then you just say, okay, bucket name, grant read access to the Lambda function. And this is all you have to do to create a least privileges policy, which includes the bucket name.
So does this create an yum role or yum policy, or does it create a bucket policy?
No, not a bucket policy. It's just the policy for the Lambda to access the bucket. So then we had the event source. And we say, okay, the Lambda function get a new S3 event, which refers to our bucket and which has some event types. We have to import this. Should import this S3 event source. Have we imported it already? I forgot one lengthy import. So we want to add AWS Lambda event sources, because S3 event sources would be the other way around. And then we could do it one time manually. That we say, okay, we import the S3 event source from the library at AWS CDK, AWS Lambda event. And this is just machine learning that he guesses I want to use event. So, okay. Why is this wrong here?
So this is something that, well, not bothers me directly, but I guess the IntelliSense TypeScript support is that good that it directly would show you what kind of resources would be available, that you don't need this guessing mechanism from tab 9. So what do you think is the benefit of tab 9 here?
It's just sometimes the problem is you first have to add a library and then use it so that IntelliSense can work with it. There's a discussion going on to use a monorepo for that, but not so good. I think I have to restart AWS Lambda event source. AWS Lambda event sources.
I think you're just missing out the S here.
Pardon?
Yeah, so you have written down event source and the package is named event sources.
Could be. Ah, really? So let's try. Ah, this is what you meant.
Yeah, this is what I meant.
So it's auto healing. And then you can say, okay, which events do I use? We have events, we could do filters, and the event it's almost the same as on your side, but we have an event type here. And we will have object created. So, and last but not least, the the table. And this is the same. We have a table, genau, table, and we are creating a table. I need a new, faster. Maybe we can call it items or something else. And then we have the properties. And the first thing is partition key. Do not know whether it's the best choice, but I thought, okay, we have just items. And so I will call it item ID. And the type would be an attribute type dot string. This is a partition key. No, not match style. Then we have a name that should be good. Maybe we should generate the name also. And we have a removal policy. Because I just, oh, it does not. Table, just take some time. Okay, then removal policy destroy. Because for production, it's not such a good thing. You could do a snapshot, but for testing, it's a good thing. So, and the last thing is that we tell our Lambda function also, okay, how is a table called? If we want to generate the name dynamically, and we refer to the table name. So, and the last thing would be that we say, okay, this Lambda function needs write and read access. And then we can say just, okay, read write data and grant it to the function. So you said about you have 80 lines. I have 54, but there are some more lines.
Yeah, so what I see here is your table is granted read and write for all of the data to the function. Is this really least privilege for what the function does, or does your function do more things than just putting an item in there?
Okay, you say I should use just write.
Well, what I say is not only just write, but just put item. If it's just put item, I don't know what the Lambda function does, because grant read and write data is kind of a lot of permissions, right?
Yes and no. It's not on the API level. It's not that you say, if you look at the grants here, it's not put, it's not get. It's more abstract to say, okay, you have management functions like create and delete the whole table. You have read functions, you have write functions. And then you have these special streaming functions, but you are not going down to the level of put object.
Yeah,
so
all
you
right.
could
So
say with S3, can say, okay, I can make put object, but no multi-part upload or something like that. But I think this is more than most people are doing. So let's have a look. We have a Lambda, we have a bucket, we have the event, we have the DynamoDB. Just an anecdote from my test with Cloud9. Because, and I think this was what took it so long, because CDK uses a Docker image to build the Lambda function. The 8 gig boot drive was not enough, and I had to do some grow parts there to use Cloud9. And Cloud9 has a construct on CDK, but at the moment you cannot give it a larger EBS. So then one thing with the integration, we have seen that you have used the AWS integrations here. There are some integrations with CDK, and we have a CDK Explorer. It's in the preview that you can see, okay, this is our work stack. Here we have the function, and you see that the role is being created, and you can go to the code and the other things down there. This is really nice. And we have the outline, because the TypeScript is a somehow object-oriented thing. This is only on the TypeScript level to see this. So now we can deploy. So 2026, almost the same. So again, I'm just doing a deploy, not doing a diff. Usually, you have to do a build upfront if you do not npx, but I'm just doing a deploy right now. And if you have multiple stacks, you have to give the stack name as a parameter also. But I have just one stack, so it's a deploy.
So, and because you used Awesome here, you don't have to put your credentials, right? Because they are exported in the environment.
Yeah. Yeah, not just because I use Awesome, I could use a profile here. That's right. But the not only the Awesome environment, there are special variables, but the standard environment variables. You know that the Python SDK uses the AWS default, and all other SDKs uses just the default variables. So it's working. It's working. And this really takes some time. So we can have a look at the Lambda. But this is also because OBS takes quite some CPU power. So looking at the Lambda, not so. I wanted to see the workspace. So we have a few more directories here. The CDK staging, where we have our assets. The parcel cache parcel is the module which creates out of the TypeScript function directly than the JavaScript function. We have here, this is the same as from the beginning, our app and our stack. And here we have the assets. If we had more time, I could show you, but you know it, CFN diagram to create a diagram out of that cool thing. And now we have the Lambda function here. And TypeScript is a little bit more readable than JavaScript, I think. We also use the AWS SDK, make a config update for the region. Then this is our communication with the infrastructure. We have seen that we put in the environment here the name of the bucket, and this is what we read here. Then we need DynamoDB client because it's TypeScript. We make an async function that gives us the opportunity to make a normal call. Usually JavaScript is asynchronously. That means you call DynamoDB put item and gives the put item a function which is called when it's done. But this is sometimes tricky. And with async, you just can say, okay, do not do something asynchronously, just wait for that. So just from logging, then we get from the event just the first record. I have done this easily. It's not a production code. We get the source key out of that. And then we have the parameters, just the put item. The item ID is the source key and the time for that. And then we put the item and gives that back to the console. That's all.
So just to ask a quick question here, as you already, in the beginning of your Lambda code, you specified a version, a region, sorry, pardon. Does this region limit us when deploying the stack to multiple regions? Because what I assume would happen if you give a region here for the AWS config, your Lambda function would try to work on that region, right?
Yeah. But it does not limit yourself because the stack is in the stack region, and the Lambda, which is deployed in Europe, could work in Asia. Yes, it has pros and cons to fix the region there, but sometimes the magic way to automatically get the region is not working so good. But the right way would be to put it in a configuration, but just to make sure it really is in Europe.
So how is the behavior of TypeScript or JavaScript then with Lambda functions here? Because what happens with Python is it uses the region the Lambda function is deployed in as the version or as the region to put API calls against. So it does not fall back to US East 1, which we know from local executions as the default, but it just uses the Lambda region where it is deployed. So how does that behave with Node.js?
Should be the same, usually.
All right.
And TypeScript is not so good supported in terms of examples and so on. And one thing which is quite annoying, but which is also the idea of TypeScript, is that you have everything as a type. But if you do not know the type up front, you have to specify that it's any. It's a little bit backwards. I think this is better in Go, where you have to specify, but it is specified. And with the TypeScript, you have an extra type library, but it's not 100%. This is getting compiled to just JavaScript. And here you see it's almost the same, but there are some more things for that. So now the container has worked. These are the things. It was more than 3.5 seconds. We always, when we deploy, the security relevant changes are stated. So we have the resources here, the assume role, and here you see the policy which is created for the read-write. And if you want to use even finer policies, then you have to override it.
Oh, all right. So you would use an override here instead of creating the EM role by yourself.
Yeah, it depends. Sometimes you just create the IAM role, and sometimes you add something, which with a CDK construct, you can also use the created node or the created CloudFormation object to add something. But normally I would stick with these as read-write, because at the moment I have not enough fantasy to have a use case where you could have get item but not batch get item.
Well, I think it depends on how your Lambda function is structured, right? So if you have a serverless application which has multiple Lambda functions behind an API and you want to separate all these functions out, you would just need one or two specific functions to interact with your data. So that could be a use case where you have multiple Lambda functions, and one is just get item and the other one would be batch get item, if you think that way. Probably might be.
Totally constructed. What I said is, with that, you are the king of least privileges. Usually I see also in production from good companies, just, okay, takes the managed role and then DynamoDB read everything. And this is the point where security breaches occur, because the thing with the large banks, this was read access to all the buckets and not only to one bucket. So what has been created, we see our CDK toolkit stack here, and then we have the work stack, and there are some resources. It's not just the Lambda function, it's IAM role for that. Some policies to put in there, the CDK metadata, which you talked about, then the function, permissions for the Lambda, another role and policy, and so on. Sometimes if I have the possibility to add the life cycle of the CloudWatch logs groups, so that they can be deleted after 30 days or so on. And for that, an extra Lambda function is created. And this is the same with the bucket functions here. Usually, you have what is called in English Henne-Ei problem, which is first. You cannot make the bucket notification before the bucket is there. And CDK resolves that in creating just another Lambda function just to do that. So, and now we have this function. And then I could do the local testing, but it's the same as with SAM. We just generate the CloudFormation, extract the name of the function and use the SAM. So switching to English here. Do not know why it switches back. Usually in production, I would not program the whole function in one monolithic block, just in a sub-function. And then I would also make a function to extract the name of the object out of the event and would test that with the JSON. But to be short, we just have an S3 put event, and this is the test key. I do not know any API function to configure a test event. That's a pity. So then we test it. And we see the records. That's usually I'm doing first step to really look at the event. And at the end, there should be key test key. And it is faster than yours. And this is because, oh, I wanted to configure 1 gig. Okay, that's the same. And we can look at DynamoDB. And then I have a multi-account, an annoying multi-account extension here. And so from the first test, I also have the item here. And the same, if I go back. Okay, this is the bucket name for that. And just a moment. Do not want to type it blindly. If we now say, okay, we copy, for instance, our README file. Hello? What is that? AWS S3 copy readme.md. And we are using the bucket name. Then we can also look at the Lambda, whether it's working. And with the CLI, you could also automatically extract the bucket names. So then we look at the table again, and there is the README. To summarize, and this also took an hour, to summarize that, how do you do it? You create the application. This bin, you really leave it as it is. Then you have to import all the modules as npm import. This will get this is the same, not the same, it's nearly the same as a requirement txt. This will get as a dependency in the package JSON. And it's really vital that you have a fixed number here, because if anything really weird is happening, look at the package JSON. And if you have something like this here, it will not work. So then you have, this is just the standard stuff. You need all the imports. Then you make the function. You can just use a Lambda function, but now for TypeScript and for Python, you have these Docker containers. And usually, if you have no OBS running, it's a little bit faster. The outputs, like yours, the bucket, it's also a construct. That means all the properties are in there with description. And I think this is a little bit easier. And the table, which is something like the simple table. And what you would do if you have a fast upload, you would do something like, I will just show you in a new file. No, here, file new. Just put it in here. You would do something like update function code, and you would create a zip file before that. And with TypeScript, that would be a TypeScript compile and do a zip file for that. So I thought at the beginning, before today, I thought it would be very much simpler to do it with the CDK. But I think at the first few resources, it seems easier on your side. But what I really love about the CDK is something like referring to the real methods and functions, and these things to have something like these privileges. And what is not so good is the slow update of these functions, but you could manage this a little bit with the update function code.
Yeah, what I think here is that CDK goes a whole lot deeper than just serverless, and I think that's where it shines, because all of your resources would be as easy as the resources you created here, where I would just need to write CloudFormation and SAM to have other resources, which, well, does not make that much of a sense. That's I think where CDK shines, because it's more general for AWS infrastructures. What bothers me a bit here is that you have to have so much modules for just simple tasks, but this is a node problem, I guess.
And you're getting used to it.
Yeah, sure.
You could say it's isolation, and you also could say the different thing is to say it's too much of an isolation.
Yeah, I think it's even harder to check all these references and all these packages and packages referencing packages and so on, because it's recursive here for security breaches. So what I have a problem with, and I think there are some good scanners out there, and I know GitHub does something as well, to automatically scan for vulnerabilities in all these packages, because you can't do it on yourself, I guess.
Yeah, if you're talking about what you do in a pipeline, there's a whole new world. And the thing that you are watching, it takes a minute. If you have a pipeline, you're not watching it, it's just working. So at the end, from my side, I wanted to show you this great tool, CFN diagram. You just call it with a stack. And after that, you get a diagram of all the created resources. And on the one hand, this is great. On the other hand, it shows you that the automatically generated diagram just has too many resources to be useful. So it takes time.
Just a question here from my side regarding the CDK output, because what I see here is it's still JSON. Is there an option to generate YAML templates out of CDK, or is it always a JSON template?
It depends on the version. It should be YAML sometimes. So, and you see here, maximize panel now going down. You see here all these additional resources which are created, our bucket notification handler. And this is the thing, if you are just working with CloudFormation, there are some limitations which are logically built into the language. And with these custom lambdas, you can get around this.
So is this the way to go with CloudFormation? I know we are going away from our topic of CDK and SAM here, talking custom resources, but what they did is also they have these custom providers, I guess I name them, where you can just create your own logic in CloudFormation, which is even more than just simple lambda functions. Have you worked with them already, or would you stick to custom resources?
I've not worked with them already, but my understanding is it's not so much different from custom resources. And I'm working with the CDK anyway, and they have a great addition to custom resources. Sometimes when we say, oh, Terraform already has these resources, in Terraform it's just API calls in the end. And if you just want to add some more API calls, I had the thing in a project with the SES identity. You can create a custom resource where you configure the API call. So it's really easy to add this. So
yeah, I think that is a great feature of custom resources here. What I think they did even better with these custom providers, I guess they have, I'm not sure here, but with these other types of custom things is that you can have your own state management, and you can have like not only logical IDs, but you can also have the AWS ARNs and managed to work on these objects you create, even like Terraform, right? Because with custom resources it gets a bit of tricky to delete resources you created with a custom resource upfront. I think from my side that it gets a bit tricky.
It depends on the project. Okay. Thank you very much. We're going to full length, I think about 2 hours. But from the amount of time, we are quite even. Maybe I've took a little bit longer, but you have in the same time discussed the Python function a little bit more. So from the only the time view, maybe sometimes with these simple things, SAM is quicker. But I think we have discussed the pros and cons for that in length. So yes, everybody's who's watching it now on Twitch or later, we will load that up to YouTube. These are our other channels: Twitch with tecRacer, then the AWS blog. This is my Twitter handle. And on GitHub, we have some more things in our repository, like CDK templates, or I think we will upload this also, the code from the Python and the JSON Lambda for the CDK. What my intention was to show really the pros and cons, because I think it's not really just stopping my screen share right now. It's not right or wrong to use this or that. I'm preferring a little bit CDK because I'm now used to it and really quick with it if my laptop is not so slow. But the tight integration of SAM into all these tools is really advantage. And so I think there's enough space in the problem and solution space for both. Marco, you have the last word.
I have the last word today. Yeah, great. Was a pleasure here, being here, having like an hour on SAM and talking all these crazy serverless stuffs and doing some hands-on here with you. I think that was great, and it showed a lot of potential in both tools and where they have their pros and cons. I already uploaded my SAM local code snippets to our tecRacer GitHub repo. Yeah, you should follow that because there are some great examples in there. And as well, you should follow our AWS blog where Gernot is very active and putting all great new stuff and tools in there and constructs. So it was a pleasure being here, and for the next time.
Okay. To all, stay healthy. And we need a catchphrase at the end. Keep on building is the same from the AWS podcast. So just bye. See you.
Bye-bye.